Hi, welcome to part 4 of the 6-part series looking at how to create a maze game using Pygame. In this part, we are going to be adding scrolling to the background, we are going to be implementing collisions, and we are going to make sure that the levels progress, that when you complete level 1, you move on to level 2. We're also going to make the title bar more informative to tell the player which level they are currently playing. In our game variables section, we are going to create a new variable called screen scroll, and we're going to set that initially to 0, 0. We are then scrolling down to the game loop, and inside the update, we are going to put a maze.update call, which is going to take the input of screen scroll. So moving back across to the maze.py file, we are now going to create this update method. So def update, and it takes in the parameter of scroll as well as the instance of itself. And for every tile that is in the map tiles array, we are going to do the same thing to it. We are going to update its X position. So the tile's X position, which is stored in position 2, is going to be increased by the amount of scroll in the first position in scroll, which is the X coordinate. We are then going to update the Y position for each tile using the item in tiles position number 3 by increasing that also by scroll, but this time looking at the item that's in position 1 in the scroll array. And then we're going to update the location of where that tile is going to be drawn on the screen. The item that is in the tile array's position 1, which is the location of the rectangle, its center is now going to be the position of tile 2, tile 3, because those are the two variables that we have changed in the tiles array. If you remember, the array holds the tile image, the rectangle, the X position, and the Y position. Moving across to character.py, and we're going to update the character class. So within the move method, we are going to implement a variable called scroll, and we're going to set that as the array 0, 0. And then underneath where we set our general movement, but before we move on to the update method, we're going to check how close the player is to the edge of the screen. And if it's close to the edge of the screen, we're going to make the background move accordingly. So if we're on the right side, we're looking to see if the right side of the character's rectangle is closer than the screen width minus the amount of scroll threshold. And if it is, we're going to set up the threshold. In our constants file. So within movement, we're going to make a constant called threshold, and I'm going to set that to the distance of the top bar, which is currently 50, plus 50 pixels. So in general, that will be 100 pixels at the moment, but if we increase the size of our top bar, that amount of padding or that threshold will vary. So if the right-hand side of the rectangle is closer to the edge than that amount of threshold, we're going to make the 0 location of the scroll, so that's the X coordinate, be equal to the width of the screen minus the threshold. And we're going to take away from that the self.rect.right position. And we're going to set the right-hand side of our rectangle to be equal to the screen width minus the threshold. Do be careful with capitalization in Python. It is case sensitive. We're going to copy and paste that code for the other side and just change the variables. So for the left side, if the left-hand side of the rectangle is less than the threshold, then we're going to set scroll 0 to be equal to the threshold minus the position of the left-hand side of the character's rectangle. And the character's left-hand side of the rectangle is going to be moved to the threshold. Copying all this again because very similar pattern between right and left as there is for top and bottom. So doing the bottom and the top. So for the top, if the top of the character's rectangle is less than the threshold, we're going to set the item in the first location in the array, so the second item, which is a Y. We're going to set that to be the threshold minus the top of the rectangle. And we're going to set the top of the rectangle to be the threshold location. And then for the bottom, we're going to set the bottom of the rectangle to be equal to the screen height minus the threshold, and the scroll 1 position to be equal to the screen height minus the threshold minus the character's bottom position. The check that we are doing is to see if the character's bottom is greater than the screen height minus the threshold. And then we are going to return the scroll value from this method. Going back to the character.py and testing this out. So now if you look, the maze moves as we move up and down the screen and as we move across. So we have screen scrolling working. So we're back on the main py.py file, and where we called the move method, we have now assigned the value of screen scroll to be equal to the value returned from the player.move method. So when I move the player, I want to pay attention to where the obstacles are to make sure that I am not trying to walk through walls. So when I move the player, I'm going to pass in the list of obstacle tiles into the character's move method. And then inside the move method, I am going to perform a check to see whether I am trying to walk into an obstacle or not. And I need to check this individually for X and Y. So we're going to split the self.rect X and the self.rect Y within the move method apart. And we're going to add a for loop in, which is going to iterate or work its way through the obstacle list. And for every obstacle in there, it's going to say, is the player's rectangle colliding with that obstacle? If it is, and we are trying to move towards the right, then we want to set the character's right-hand side of their shape to the left-hand side of the obstacle, which is stored in the obstacle 1, because each obstacle consists of an array. So it's the second value in the obstacle array and the left value of that, because the second value in the obstacle array is the rectangle for the obstacle tile. If the direction we're moving is negative, i.e. we're moving to the left, we're going to set the character's left-hand side of its rectangle to be equal to the right-hand side of the obstacle's rectangle. We're then going to copy and paste that code and adapt it for the Y variable. So we're going to want to change the DXs to DYs. We're going to want to change the rights to bottoms, the lefts to tops. Moving back to main, and let's test this out to check that walls can't be walked through. And as you can see, when we run it, we can't walk through the walls. We can't skip all our way to the end. So moving our way through the maze, trying to find the ladder, we get to the ladder. And at the moment, this does nothing, which is not an enjoyable experience. You want to know that if you reach the end of the level, you're going to move on. So we're going to create a new game variable called level complete, and we're going to set it to false to begin with because we haven't yet completed the level. Moving back to the character, we are now going to write part of the move method that asks, have we reached the ladder? So we are now bringing in the exit tile, and we have added that into our move declaration. So if the rectangle for the exit has collided with the rectangle of the player, we want to see, is the player close enough, or has it somehow managed to reach through a wall to get it? So we're going to look to see what is the distance between the ladder and the player, and if it is close enough, then good job, they can move on to the next level. We're going to utilize a mathematical formula to calculate the distance to the exit, and we're going to use math.square root, and inside this we are going to square the result of what you get if you subtract the center x position of the exit from the center x position of the player. And we're going to add that to the difference between the center Y position of the player and the center Y position of the exit. And then we're going to take the general square root of it all. And if that distance is less than 20, we are going to say that the level has been completed, and complete is true. We are then going to, at the bottom of our move method, return the value complete. What I did forget to say was we're going to, at the top of our move method, initialize complete as false, so that if this isn't met, then false is returned. And within the move method, we are going to want to have returned whether we have, as a player, reached the ladder. So we're going to return from the move method something called level complete. And in order for the character class to know whether it's reached the end of the level and therefore completed the level, we need to pass it the location of the exit tile. If they do complete the level, we want to say what to do within our game loop. So if the level has been completed, we want to increase the level number by 1. We want to set that we have now no longer completed the level because we've moved on to the next one. And we want to set up the new maze and store the new maze, the new player, and whether we have finished the game or not in the variables when we have created the new maze level. So testing this out, when we run the game and we work our way through it, this time when we reach the ladder, we move on to level 2. What we do want, though, is to make sure that the top bar at the top tells us what level we're on. So we're going to go into our top bar, and where it currently says maze game, we're going to change that to read F, and then inside the quotation marks level, and then curly brackets level, close curly brackets. And this will extract the value of level and put it at the top of the screen instead of just the words maze game. And testing that out, you can see that as we move through the levels do indeed update. So join us in the next part to congratulate the player when they complete the game, and also to make the transitions between the levels much more interesting with a fade effect.